We're going to get started with our PyTorch LSTM. Today we're going to do training. We're going to do training today. I'm really excited about this. This means that we have the ability to get our model to learn. This is the training part of the model. This is the part I'm really excited about. It took us a while to get here because we had a lot of little details that we need to learn, especially with the loss criterion that we were dealing with. That's one of the things that took us a little while to figure out. I'm going to do a couple of things really quick on my screen, and so that way you all can't see what's going on. Okay, so I want to update this. It's going to be what should we call this? This is going to be called the mask. All right, I think we're just going to call this the mask. Keep it really easy.
Undisclosed use of AI while coding.
Whoop.
Yeah, that's an actionable.
another video played. I did. That was This is Prime over here. I'd want to watch that one. I'll watch that one later. All right, I forgot to loop the audio. There we go. Loop. There we go. All right. Second like is mine. All right. Thank you, the Dreamer. Good to have you here. So we're gonna add in a mask. This is a tag mask, and it's going to be set to the length. I believe just the length of the tags. Let's try that. Let's see if that works. I think it might work. So let's get rid of the print there. We don't need any of that for now. We're just gonna load those, and we're gonna build them once. Okay. I think this will do the trick. We should also do the same thing for a dictionary. This will be dictionary. Update. This will be a mask length of the dictionary. Okay, that should do the trick. I think that should be fine. I think we should be good to go there. Now, let's rebuild those and print them out. Let's rebuild and print those out. So it's the dictionary and the tags. And we should be good to go. Let me disable the training and rerun it. Wait. RM and Python full. Okay. Oh, right. Because they're already gone. Sure, fine. Okay. Here we go. Okay. So our mask is 3. Yep, there it is right there. And mask is 9. Hey, programmatic solution. There we go. That's the way I like to see it. So let's see if we can get our training started now. We might finish this really fast. Bridge gap between your dream and real life is action. Only thing that fills the gap. That's the only thing that fills the gap. Quoted by the Dreamer. Got to bridge those gaps. Had some interesting dreams. Last night. Some interesting dreams. What was it? We were phasing. Our transportation. I don't know. In your dreams, do you ever have abilities or some like uncommon things happen, like things that shouldn't happen in real life? Do you ever have that? Do you guys have that? I'm curious about that. Okay. So I want to continue on this. This is actually great. This will be great. This will be nice, simple, easy to go. Do you guys ever have special powers in your dreams? Okay. I think we're good to go. Let's run it through one epoch and see if that looks good. Okay. That looks great. No errors. All right. That's good. Because we added. 1 second though. 1 second. We need to do. How are we doing this here? This part right here. Nice. It's all automatic. Okay, good. So we have our target inputs and our target outputs. Excellent. Hey, Jinlu. Handsome. Oh, well, thank you. You. All right. So we get our delta. Did we print the delta? We got the delta right here, right? This is the final negative likelihood loss. Now we can run backward on the delta to generate our gradient. Oh, okay. Trying to backward through the graph a second time. No, just once. They're doing it just once. Oh, wait, we got a zero grad. All right, let's do it here. No, wait. Do we do it right before the forward? Oh, here, okay. Here, let's see here. I'm gonna do that. All right, let's do that here. Index and labels. Okay. All right, let's try this. Wait, is out the correct? Yes, is that correct? Out, index. Wait, no. Oh, okay, I see what's going on. All right, so since we did it in the batch, we're gonna have to do a little bit differently, right? We're gonna have to do it a smidgen differently. All right, let's undo that. Let's bring that batch back. Here we go. We have to do that here. Maybe. Let me think about it. Yeah, we can only do it once, but we get different loss criterion for each because of negative log legacy code. And so since we're doing it through a batch, okay, we need to think this through, you guys. The framework's like, nope. You want to do the thing you wanted to do? Oh, you did? Sorry, not gonna work. Okay. Okay, let's see if there's any more details. Let's read through this error real quick. All right. Trying to backward through the graph a second time or directly access the tensors after they've already been freed. Oh, save intermediate values of the graph are freed when you call backward. So I can only call it once, even though I got the full thing. So how am I gonna get the delta from the batch if the criterion... Okay, so we understand why now. We know what the problem is. So what we're gonna have to do is we're gonna have to run through every sentence independently, I guess. I don't want to do it. I didn't want to. I always wanted to do the batch, but it's gonna zero out our gradients when we run backward for the first time. All the inputs on the inputs, so, or the outputs rather, right? Or that the whole thing. So you know what? We won't see any errors this time, right? No errors this time. Not a single error. Not a single error. Boom. No errors. All right, we did our backward. Do we have our optimizer? We have our optimizer. Where's that? So we got our optim, SGD. Okay, we got our SGD. So we're going to do optim.step. So that way the model can learn. All right, we're gonna train the model. We're gonna see if we can print those out. And then we have to do inputs here. Inputs. We could do unsqueeze here. We could. Let's do it like that for now. Output in. Oh, we don't need this anymore, right? Because it's gonna be label. Here, I've got an idea. Label equals labels the index like that, and their features feature sentence. Let's just do sentence. It's easier. Sentence, and then this will be features. 8th time. Number 8. There we go. Got 8 going, you guys. 8 of them. All right. Label sentence. Let's put in the right order. And then we need to print all this stuff out. Let's just hide everything for now. We're not going to deal with all this other stuff here. No breaking necessary anymore because we're going to do this the way they wanted us to do it. And then we're going to also need this. 0 the grads. There we go. Number 9. We get number 9, you guys. All right, let's try that. Here we go. Shape is not a feature. What? List object has no feature. It's a list object? It is? No. It is? Or well, let's print features in. Yeah, let's do a break. Let's actually do a break here. Break. So we don't need to redo that over and over. So let's print features. What's going on? What is features? Here we go. Nobody can beat your broken. Yep. Nobody can beat. Yep. You got it. It is a list. Then how did we make it work before? Does it auto convert it on our forward sentences? Maybe it does. Maybe it does. I thought we needed to make it a tensor. Oh, you're over there on the purple. Good to see ya on the purple. I am excited about that. If we get more people on the purple as well, then we can become then we can enable subscriptions. We don't have enough people on the purple for subscriptions right now. We don't. No, I'm talking about Twitch. The purple Twitch. Okay, so this is where am I printing feature? Oh, but I made it a tensor right here. I spelled it wrong. You guys. It's Steven's spelling issues again. All right. It's because of that right there. Okay. Now we're good. All right. Perfect. Did we? Oh, wait. Our mask. Let's update our mask. So we get our mask is going to be the length of the dictionary. We need to update the dictionary to support a mask, which is going to be here. It needs to be the lang of the dictionary. There we go. There we go. The latency on YouTube is like 10 to 50 seconds. It's crazy. Is it really? No way! And so over there on Twitch, it's a little bit faster. We got some latency on YouTube, you guys. You have more viewers on Red, man. Yep, Red rocks. Yep, we got more viewers on Red. You got it. Good to have you guys here over on Red. We sure do. Well, because we started on Red first, right? We started on YouTube a few years earlier. And then Twitch just only somewhat recently. The background changes to some tough decisions is about to take. What are those? What are those? Yeah, it's like 10 seconds or less. A little bit. Okay, all right. I mean, it's not that bad, but you know, the music got intense. Yeah, the background music. A little about tough decisions, you guys. Tough decisions. So let me double check that this is correct. Is our dictionary, the mask should be 10. So, will it be 10? Will it be 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, the dictionary's wrong. Okay, we gotta fix the dictionary. We found a bug. The same with the mask. Do we need to do -1? We gotta do -1, that's why. Okay. When we do this, we have to say -1. -1. Like that. And then we need to update the mask here as well as a -1. See, you guys, the little things, right? Okay, now we need to delete the dictionary again, and it needs to be 1, 2, 3, 4, 5, 6. Wait, start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 10. Should it be 10? Or should it be 9? It should be 9 is the answer. 9 should be the answer, right? I think so. Should be 9, yes. So then when we're doing this as well here, when we're putting in the mask, we have to do -1, like that. Or we could just say dictionary mask. Let's just do that instead, right? Mask, there we go. So that way we know what's what. Now we know what's what, right? Now we know. And the same thing for the tags as well. Do we need that to do over here? Or 0, it's gonna be this. And it will be tag. There we go. There we go, you guys. Whoa. Oh, wait. We can't. Oh, no, that's fine. This is the vectorizer. Okay, we're good. Okay. You explored Open Router all day, and you can say one thing. The bring your own key is broken and only working on Gemini models for you. Oh, is it really? Oh, no. So you can Open Router only using Gemini. Okay. All right. Where are we at in our code here? So we had a problem. So now we've got the correct. Yeah, we got everything correct. And the mask is showing up properly now. Yep, the mask is padded correctly. Nice. Okay. We're good to go now. We're good to go. Let's get back to our training, you guys. The goal for today, we have to get this working. We have to. We're so close. There's almost nothing left to do here. The thing is, our tags and our outputs are broken. And maybe the same thing with our dictionary, because I'm not seeing any zeros. See, I'm not seeing any determinants. And we should see a determinant, and we don't see a single one, right? Because our determinant would be here. All should be, and they all are, oh no, maybe they are 9. Are they? No, they're set to mask. The determinant should be 0, because we're looking at the dictionary right here. So we should see 0s, not 9s. Why are we seeing 9s? It didn't make any sense. This part's working, but the determinant, oh, I think I know why. Hold on. I might have a short circuit. Okay. This resolves to 0. And because it resolves to 0, it's turning into a mask. Which might be okay because the determinant has no meaning whatsoever. However, I understand it. And the same thing is happening as well for our tags. So it's not getting a 0. So let's go ahead and do our unsqueezing here. And I'm going to do it differently. Hold on. Python import torch. Let's say a equals torch.tensor. And we'll say 1, 2. All right, a dot unsqueeze, squeeze. And we need to say 0. Yeah, unsqueeze 0. We need to unsqueeze 1. Yeah, unsqueeze 0. Okay. So we need to unsqueeze 0 on this. I think unsqueeze 0. Are we using this somewhere else? Yeah, we are right there. What's going on here? Why are we using that here? Oh, we don't need to anymore. Okay, so that right there. Should we get the model out? Let's see here. And it's still gonna give me an error? Still gonna give me an error. Because of this right here. So let me see what 0 looks like. And let's see this. And then we're just going to return out before we even go into it so we don't see the error. Okay. So, do we even need to unsqueeze? I think we still need to unsqueeze it. Okay. So those are similar. The only thing is unsqueeze 0 is not going to match this view. Let's try this. See if that does any difference. No, still not good? Okay. We had it working before in the batch. So now we need to make sure that it's a 3D tensor on the input to the LSTM. Where the batch happens, we had to unravel the batch. The batching was going to happen here. So what I did was in our vectorize, it's going to create all of our training data. It's going to vectorize it and convert it into numbers, right? These numbers here, which is our, I see you didn't see that very well. So this is our dictionary. We're going to convert our input data, which is up here. Here, this is our input data. And so it's toy data, right? It's just a small amount of data. So this is our input data. What we're going to do is we're going to vectorize these words into numbers. So that way they match up with this dictionary lookup. We're tokenizing, right? We're tokenizing. Same with the tags. So that way, because AI likes numbers. And when you're throwing numbers into an embedding, it wants a token number, an ID, right? So instead of you doing your own one-hot encoding, when you typically do in a feed-forward neural network, we're only going to pass in the token ID. Same thing for our output on our negative log likelihood loss needs to happen here. And it wants IDs for the tokens on the output as well. So you can create a small language model using LSTM if you want your tokens to also be words on your output. In our case, our tokens are going to be classifications. So that's what we're doing here. Also, I think I deleted something by accident. I think I got rid of our activation. We did. Okay, so I need to add our activation back. Where's that at here? For soft. I need to bring that back. Bring our activation back here. So now we've got everything in line with the tutorial. However, instead of using the view, the weird view that they had there, we're just using unsqueeze, which is a lot easier. That's a lot easier to use. It's a lot easier, a lot quicker, right? Where did they have it here? So I think they were using this view, which they don't use anymore. And this will train our model. If everything's in the right spot, it should work. If everything's in the right spot, it should work. Okay. So I'm actually kind of curious, you guys. Where are we at here? 0. Let's reload that. I'm going to ask you guys a question. Here we go. Start a poll. All right. Success or fail? Will the model learn. Curious about that. Here we go, you guys. Okay. I think it will. I think it will, because we already proved that this part works here. The criterion should work because we're only targeting the sentence, right? Only one sentence at a time. We're gonna tags here. Let's see, we can just do tags like this. Tags. Like that. I think we should be good to go. I think it's gonna work, you guys. I think it's gonna work. Long short-term memory. Yep. Yep, there we go. So where's the area to innovate with the LSTM? Long-term memory or short-term memory? The long short-term memory, right? Both. So this is the precursor to a transformer. A transformer is the current, as far as I know, state of the art. There's newer versions and stuff out there that people are experimenting with right now. Transformer is like ChatGPT, Anthropic, Gemini. They are the next level to an LSTM. They provide some of the similar benefits. The only thing is the LSTM only has attention for words in sequence. A transformer has attention for every input segment. So everything all at once, because it attends to everything. This is a new AI will be alive. It will? AGI? Transformers, Onyx, SQL Rel. You're saying a whole bunch of things there, YOLO. What are you doing, Anasazi? Those SQL, one of those things isn't like the other. Something's out of order there. Okay, here we go. Let's see if it works, you guys. No errors. No errors. Oh, no. Only batches of spatial targets support 3D tensors, but got targets of dimension 1. Okay. So that's our tags here. Okay, so this part should work fine. Okay, unsqueeze it again. Unsqueeze a second time. Do we need to unsqueeze it? Are we doing this properly? Like, no, it doesn't. I'm like, how's it going there, Prod by Core? Welcome on in. Happy Wednesday. Good to have you here. Let's see if we unsqueeze it again. Is that going to be enough? Is that what it wants? If that's what it wants, try it. Now it is a 3D tensor. Expected input batch 7 to match target batch size 1. That should work. Here we go. Okay, where are we at now? Oh, okay. How about that? There we go. That's what it wants. Maybe. Let's see. Let's find out. Maybe. Maybe. No. Okay. Still no. Okay. All right. Expected input batch 7 to match target size batch of 1. But we made it better though. 1, not 0. I thought I saw it said batch size of 1. So it does say batch size of 1, but really, wait, expected input batch 7 to match target. So it still thinks that target is a batch of 1. Did we had it right? I mean, I thought we had it right before, because we did this. We did this earlier, and it was actually working. We actually had this successfully working. So what we could do is we could go check our GitHub really quick. Let's go here, GitHub. Go to our project repositories. Look for the tutorial. It's called LSTM. Where are we at here? LSTM full. Here we go. So here's our original. This was working before. Out index. What does our output look like? Yeah, this is 1. Do we need to unsqueeze our output maybe? We might need to unsqueeze our output. Or we might need to squeeze our output. See it on screen. Uname, right there. A little bit of uname, if you're familiar. Okay, so it was the way we learned it over the last couple of days. Negative log likelihood loss it does want, it really does want the tokens. It doesn't want the one hot. Isn't that crazy? It's like, it went back and forth. I'm like, no, it really wants the one hot. No, it wants the tokens. You have white matter disaster. Oh no, thinking is above your head. Oh, at the moment, seriously, Walking Beauty? Well, you can the stream chat will do the thinking for you. We'll do the thinking for you. No worries, no worries. I'm so happy. All right, we did it, you guys. Thank goodness. Okay. All right, back propagation time. Back propagation time, you guys. Here we go. Delta, that backward, and optimize. Let's see if it works. Let's see if it works. Moment of truth. Here we go. Smooths everything out. RMS prop is fine for certain scenarios. However, AdamW is going to give you the fastest training. Status. I'm gonna commit again. Git commit. We updated hypers with a lower LR. There we go.